Today we're going to be looking at the area between two curves. Now previously we looked at the area under a curve and we're going to use that to help us find the area between them. In this picture here I would like to find the area in here between the blue curve and the purple curve. And the strategy I'm going to use for that is I'm going to find the area underneath the blue curve, so that whole area there I'm going to work out. And then I'm going to find the area under the purple curve, so that one there. And then what I'm going to do is I'm going to subtract that purple area from the blue area. And what I'm left with when I subtract that area is just the area in between the two. So I'm going to integrate the top curve, I'm going to integrate the bottom curve, and I'm going to be doing a subtraction. Now we tend to do this in one go. It's not like when we had separate areas above and below the x-axis and you really have to calculate them separately. In this instance we'd do them at the same time. This is the example on page 14. We're asked to find the area between the two curves y equals 6 minus 3x squared, which looks a bit like this, and y equals negative 3 minus 2x squared, which looks a bit like this. Now we're looking for this whole area in between here. So I'm going to integrate top curve take away bottom curve. I need some limits, so I need to know these 2 points of intersection here. So my first job is to find the points of intersection so I can use them for my limits. So I want to know when 6 minus 3x squared is also negative 3 minus 2x squared. So this is a simultaneous equation, so we're using y equals 6 minus 3x squared and y equals negative 3 minus 2x squared. I want them to both be true, so I'm going to make them equal to each other. I'm rearranging, so bringing all the numbers to the side, x squared to this side, so 9 is x squared, and that means x is the square root of 9, which is either plus or minus 3. So these points here are plus or minus 3. So now I have my limits. So I'm going to go ahead and integrate between these two, between the limits, upper limit of 3, a lower limit of negative 3. Now the top curve is 6 minus 3x squared. And from that I want to subtract the bottom curve, which is negative 3 minus 2x squared. Now here I am going to evaluate all of this before I integrate. So I've got 6 minus 3, which is 6 plus 3, which is 9. And then I've got negative 3x squared minus 2x squared, which is plus 2x squared. So negative 3x squared plus 2x squared is just negative 1x squared. And now I can differentiate. No, I can't. I can integrate. Okay, so 9x minus x cubed over 3. I have integrated, so I'm losing the integral sign and I'm using the square brackets, and I'm still keeping my units in there. I'm now going to substitute in the upper limit and subtract the lower limit. So in rounded brackets. So I've got 9 lots of 3 minus 3 cubed over 3, take away 9 lots of negative 3 minus negative 3 cubed over 3. Now that's equal to 27. Take away 3 cubed is 27, divided by 3 is 9, minus 9 times negative 3 is negative 27. Negative 3 cubed is negative 27. So I've got negative 27 here, divided by 3, which is negative 9, but it's take away negative 9, so that's going to be plus 9. (27) take away 9 is 18, minus negative 27 plus 9 is negative 18, so that's 18 plus 18, which gives us an area of 36 units squared. The things you need to be careful with in this type of question are when you begin the integration, you must do the top curve, take away the bottom curve, not the bottom curve, take away the top curve. So the curve that is furthest away from 0, the highest up curve, take away the lowest curve. And then the same as when we did the definite integrals before, when you're substituting, be very careful with negative numbers and keep those rounded brackets in until you've evaluated each one to minimise the likelihood of making a small arithmetic error which will get you into trouble. Okay.